Last lecture we have seen metric interpretation of solving differential equation, and we have started solving some differential equations, finding out their solutions, variable separable, and substitution. After substitution you get variable separable. Next is of differential equation. No problem. I don't know what is this. Just a moment. Okay. It is very simple. Let me give you first example. X plus y dx minus x minus y dy is equal to 0. Okay. So you will find the degree of each term is exactly same, and this is example 1. It is exactly same. Therefore, a substitution. Check whether you can solve this. Solve this. Function x comma y is said to be homogeneous of degree k in x and y if and only if f of lambda times x comma lambda times y is equal to lambda raised to k times f of x comma y. It is simple. I mean, we have done this in POL also. Homogeneous equation in x and y. It has got this typical property. For example, you have x cube x square plus xy minus 2y square. Then you can substitute lambda x in case of x square plus lambda x into lambda y minus 2 lambda y bracket square, and you will end up getting lambda square inside bracket x square plus xy minus 2y square. So this is a simple meaning of homogeneous equation. I mean, it is in general true. Nothing related to differential equations. This is in general the definition of homogeneous equation. Now, for us, we have a function with x. As far as differential equation is concerned, we have some m x comma y associated with dx, and we have nx comma y associated with dy is equal to 0. Suppose our differential equation is something like this. Every differential equation you can write it like this. Then if we will call this homogeneous differential equation provided, I mean, degree of m x comma y, degree of n x comma y are same, and therefore there is a method by which we can solve it. So practically this thing gets cancelled when it gets into ratio form, and the idea to deal with it is simple. Okay, substitution. Y is equal to Zx. Okay, so if we substitute y is equal to Zx, let me solve the instead of solving in general differential equation, let me solve the one which we have. X plus Zx times dx minus x minus Zx times dy. Sorry, if y is equal to Zx, then we have to differentiate it with respect to x. So dy by dx is equal to z into different derivative of x in z plus x into derivative of z dz by dx. Okay. So maybe the first step that we should do in our case is, instead of this, dy by dx is equal to x plus y upon x minus y. Therefore, if we do this substitution now, we get z plus x dz by dx is equal to x gets cancelled and you get 1 plus z upon 1 minus z is going to be variable separable. Check and solve now. So essentially, if you happen to have a homogeneous equation, differential equation, you are supposed to substitute y is equal to zx. So if you simplify this and try to do variable separable, you will get this equation eventually, and you should solve it. After integrating, what you will get here is, we have to separate these two terms. 1 upon 1 plus z square is tan inverse z, and z upon 1 plus z square is minus half log 1 plus z square. This is LHS is equal to log x, which is RHS plus C, whatever, and therefore the final answer will be tan inverse y by x is equal to log radical x square plus y square plus c. This is the answer for first. Okay, example second. And the same trick is going to work. Only thing is that you have to identify that it is a homogeneous equation in x and y. Very simple. Example 2. X square plus 3xy plus y square dx minus x square dy is equal to 0. Get me the answer. Put y is equal to zx and solve variable separable in z and x. You will get final answer log mod x plus x upon x plus y is equal to constant. One more of homogeneous type. Y square minus x square divided by dx is equal to xy divided by dx. Get me the answer in the form y by x is equal to. Okay, answer for this third problem is y by x is equal to minus log mod y plus c. If anybody wants me to write the complete solution, I can write. But otherwise, we are moving. Okay, so now definition. If the equation px comma y dx plus qx comma y dy is equal to 0, is exact, then for some function u of x comma y, we have p of x comma y dx plus q of x comma y dy is equal to 0. I mean, this is the definition of what do we mean by exact differential equation. Say, for example, suppose we start in this direction. X square plus xy is equal to constant. Suppose we have this equation with us. Okay, so basically it is x square plus xy is equal to constant. So what we do is we differentiate this, we get 2x plus x dy by dx plus y is equal to 0, and then if we simplify this, we get 2x plus y times dx plus x dy is equal to 0. Okay, so if we follow, it is easy because we have been given a function and we are differentiating and separating the coefficients, I mean with differential coefficients, and writing it like a differential equation like this. But then if I am being given like this, solve this differential equation, that means we are supposed to go from this side to this side, right? And therefore we will call this differential equation exact because we achieve this expression by differentiating this u of x comma y. Okay, so it is slightly opposite direction, journey is in opposite direction, and therefore we have to be very alert in seeing, is this given equation an exact differential equation? Can we cross check by looking at, and then when you start thinking in that direction by looking at these coefficients, you will start getting an idea. And maybe the first thing that you should do is you separate them, 2x dx plus y dx plus x dy is equal to 0. And then try to try to do something. Normally 2x dx is going to give the first term, and these two will get combined with each other. That is what a feeling you will eventually develop once you deal with this kind of equations, more number of equations. Okay, So by this I can say if it is 2 dx, then there must be a term x square, and if there is, this is u into derivative of v plus derivative of u, then we can guess that this should be xy, and right hand side is 0, therefore it must be derivative of constant, and then you can directly get the equation. So this kind of equations, differential equations, which are given to you will be called exact. So I have told you all the story. Let us check whether you can retrieve back. Example, 3x square y plus 2xy dx plus x cube plus x square plus 2y dy is equal to 0. Now, this is not homogeneous, this is not variable separable. So it is a difficult differential equation, but because I am talking about exact for the first time, this is exact. So can you cross check and find out whose derivative is this LHS, which we can write eventually as is equal to derivative of u of x comma y, and then integrating both sides we get direct function is equal to c u of, so after integrating you get u of x comma y is equal to c as a solution of given differential equation. So just check by trial and error if you can arrive at the original function. If you could identify that the given differential equation is of exact type, and by doing some trials, if you could arrive at an expression like this, maybe that is the best way to solve it. But then our life is not so easy. Maybe I will give you one more example so that you feel happy about yourself for time being, but it is not going to be the case every time. Y square dx plus 2xy dy is equal to 0. Okay, this is instantaneous. Solution of this differential equation is y square x is equal to constant. Now, this is homogeneous also. Therefore, you can solve it by that method also. Yes. So now, this is yet another example. And now what I want to tell you is, say for example, next, y dx minus x dy is equal to 0. Try your luck. Now understand what I am trying to tell you. This is easy job for you because it is variable separable, homogeneous. Whatever way you want to solve it, you will be able to solve. So solving this differential equation is not the question. The question is whether this differential equation is exact or not. And you will see that this equation is not exact because it is not the derivative of a simple looking function. However, very important, if I multiply this by 1 upon y square, if I multiply LHS and RHS by 1 upon y square, I get y dx minus x dy upon y square is equal to 0. So multiply by y raised to minus 2. That is the important step I am conducting right now. And then if I multiply it by y square, because RHS is 0, we don't have any problem in multiplication. And now if you observe this, this is y into dx minus x into dy upon y square is the derivative of x upon y. This is the derivative of x upon y. And hence, after integrating, I will get the answer x upon y is equal to constant. Okay, so originally it is not exact. I multiplied it by some algebraic term or terms and I converted it into exact, and hence I could solve it. Because this was easy, otherwise you could get the solution exactly looking like this otherwise also. But this is very important method of solving a differential equation. And hence the multiplier that we are going to use to make it exact is called integrating factor. The multiplier is called integrating factor. Okay, so if you could figure out what should be the integrating factor and multiply the given differential equation, which otherwise is not solvable. I mean, this was solvable, but which otherwise is not solvable. This is going to be a wonderful way of solving differential equation. Can you tell me whether this is exact or not? Another example: 2y dx plus x dy is equal to 0. Is this exact? I mean, don't solve it, just check whether it is exact or not, and maybe try to find out the integrating factor. Okay, as such it is not exact, but if we multiply by x, 2xy dx plus x square dy is equal to 0, then it is d of x square y, and hence is equal to 0, and hence the solution of this is x square y is equal to c, and the integrating factor is x in this case. Okay, now this is good method of solving a difficult differential equation, but what are the dangerous things that we are doing? We must be alert about them, and if at all we are getting some wrong results, eventually we should know why we are getting the wrong results. Now, in the first problem, my integrating factor was y raised to minus 2. So I am additionally introducing a discontinuity in the function. Now, y upon x is equal to c is my final solution of differential equation, but then y is 0. If y is 0 is a discontinuity that I am. So when I am multiplying by y raised to minus 2, I am introducing a discontinuity in the differential equation, and therefore once you get the solution of differential equation, you should verify whether the integrating factor has introduced some unnecessary discontinuities. That is one part. And second part, because we have got integrating factor unnecessarily multiplied to the given differential equation, are we unnecessarily creating some solutions, additional extraneous solutions? See, in polynomials, when we squared for solving, when we used to square LHS and RHS and then simplify, we may end up getting few extra roots of that polynomial which might not satisfy the original equation. So we have to remove them by picking them in the end, trying to put it in the original equation and separate them out, because they are the ones which you will get algebraically, but in between you have done a process of squaring where unnecessary roots are included in that solution. That is, those are called extraneous roots. So here also there is a chance that you are unnecessarily introducing some solutions of differential equations which actually are not satisfying the given differential equation. So if we check these two things, are we introducing any additional discontinuities? and are you introducing some extraneous roots or not, we have to be careful about it and then report the final answer of the differential equation. Typically in multiple choice questions, you may end up having some extra solutions which are introduced because of integrating factor. And algebraically, eventually you will get it once you solve it. But then if that solution is not satisfying the original differential equation, it is not correct solution. Okay. Can you tell me whether this is exact or not? X dy minus y dx upon x square plus y square is equal to 0. Is this exact? Check. What is this? What is this derivative of? Yes, this is exact differential equation and it is the LHS is the derivative of tan inverse y by x. Let me give you one more because we are discussing the same and then move on. X dx plus y dy divided by x square plus y square. Find out whether this is exact and whose derivative is this. This is easier relatively. Now this is the derivative of this function, half log x square plus y square. Okay, so now let us move. This is good idea. Multiplying by some term to make it exact, and the moment it is exact we can immediately find out the solution. Definition. A differential equation of the first order is said to be linear if it can be written in the form dy by dx plus py is equal to q, where p and q are functions of x or constants. Okay, so that is what linear first order differential equation, FOAD, first order linear differential equation. It will be referred to as FOAD and it should be of the form differential coefficient dy by dx plus some function of x times y is equal to function of x. Okay, and now we wish to solve this. Let us try to develop the method to solve FOAD. Okay, so first let us cross multiply and see what we get. Simplify. This implies dy plus, let me write it like px because p is a function of x, y dx minus q is a function of x, dx is equal to 0. Now there is no way that we can say that this is exact, because if it is, then here itself we will write down the solution, and maybe the exact, whether this is exact or not, will depend on these q and p's also. But independent of q's and p's, let us see if we can convert this differential equation in the form exact type. Okay. So the technique that we are going to use is multiply by some function. So let u of x is such function with which we multiply. Okay, I don't need to write. So let us write down. Suppose we find out a function. We need to find out u of x, but then suppose we are successful, then we will say that u of x times dy plus u of x times p of x times y dx minus u of x times q of x times dx is equal to 0. Is that correct? Yes. U of x times px plus okay. So now what is left with us if we observe this equation? If we take this to RHS, then we are left with u of x into dy plus u of x into p of x into y dx is equal to u of x into q of x into dx. That is what we get, and this in total is a function of x. Therefore RHS, we can say RHS is exact, because we will get some, after integrating this, we will get some function of x is equal to constant in RHS, right? And therefore what we need is LHS to be equal to LHS to be equal to exact. We need LHS to be exact, and it should be equal to 0, so that both of them are equal. So I pause and recollect. Now if you see these two terms, is u of x into derivative of y. So if I multiply u of x by y, then and write it like this, then its first term is going to coincide. Derivative of u of x into derivative of y, and what will be my second term is equal to u of x into derivative of y plus y into derivative of u of x. This will be my second term. Okay, and now if I compare these two, then u of x into dy is my first term. Therefore I am done if y d of u of x is equal to y u of x into p of x into dx. If these two quantities are equal, then I will be able to say that LHS of this expression is derivative of u of x into y, and RHS of this expression is function of some x, and therefore they should be equal. So now I am left with only this to be resolved. Okay, so I can cancel y from both sides, cancel y, and I can take d of u of x upon u of x, which is in the RHS, is equal to p of x dx. That is the expression which we get, and I think getting u of x now is going to be easier because this is variable separable differential equation. So log u of x is equal to integral p of x dx, and hence u of x is equal to e raised to integral p of x dx. We wanted to search for integrating factor u of x, with which if we multiply the first order linear differential equation, we convert it into an exact form. And now if we get this integrating factor, u of x is e raised to integral p of x dx, then LHS is d of e raised to integral p of x dx into y. LHS of this is equal to integral e raised to integral p of x dx, that is your u of x, into q of x dx. Okay. Now, is this correct? Is this integral sign correct? This is derivative of this, and no, I think this integral we have to remove because I am writing it in the derivative form. Okay, so if you want to solve this differential equation, given differential equation, you integrate LHS and integrate RHS. Therefore, eventually you will be required to find out integration of this term and write LHS like this, e raised to, of course, you have to find out integration of this term also. I hope it is clear. I have explained it in bits and pieces, but okay, using this theory, solve this differential equation. Question 1. dy by dx plus y e raised to minus x. Okay, integrating factor is e raised to integral 1 dx, which is equal to e raised to x. And therefore, final answer is y is equal to x plus c e raised to x. Once you get integrating factor, you should use this last formula to report the answer. Basically, it is, in this case, if we want to find out, it is e raised to x is our integrating factor times y is equal to integrating factor e raised to x into our q of x was e raised to minus x dx integral. This is going to be your solution. Then this is also, it seems this is also easy. Here itself you should add c plus c because you are integrating both sides. For this answer, question number 2. dy by dx plus y sec x is equal to tan x. Correction in earlier answer, it should be e raised to minus x. Let me write down the solution of this. Integrating factor e raised to integral sec x dx, which is equal to e raised to log sec x plus tan x, which is equal to sec x plus tan x. So we have got our integrating factor. Therefore, sec x plus tan x times y is equal to integral of sec x plus tan x. This is our integrating factor into tan x is our q of x dx, which is sec x tan x plus tan square x. So it is easy. Sec x tan x will convert into integral sec tan x will be sec x plus tan x. So final integral after you solve this is sec x plus tan x minus x plus c. And you express this as what? Y is equal to. So y is equal to c minus x upon sec x plus tan x overall plus 1. This is your answer. Okay. Question 3. Y dx plus x minus y square dy is equal to 0. First of all, you have to arrange it in such a way that it looks like FOLD. So it is dx by dy plus 1 upon y times x is equal to y. Now, here the roles are changed. This is FOLD where dependent variable is x and independent is y. Something like this. Okay, therefore integrating factor e raised to integral 1 upon y dy, which is equal to log y. E raised to log y is y. So integrating factor is y. And therefore y integrating factor times x is equal to solution directly. Integral of integrating factor into RHS into dy, which is equal to plus c, which is equal to yx is equal to y cube by 3 plus c. That is your answer. The only difficulty was it has to be considered as dx by dy instead of dy by dx. Let us solve few more so that you are used to solving the FOLD, and FOLD is favorite of IIT people. They ask questions on this. Okay. Fourth problem. 1 minus x square dy by dx plus 2xy is equal to x into 1 minus x square raised to half. Okay, I will write down integrating factor comes out to be 1 upon 1 minus x square, and answer comes out to be what? Is equal to radical 1 minus x square plus c times 1 minus x square. Okay. Then next problem. Next problem is question 5. Change in color green. 2 times y minus 4x square dx plus x dy is equal to 0. Report your answer as something equal to C. Okay, in this case, integrating factor was x square and solution is x square y minus 2x fourth is equal to C. Sixth, radical a square plus x square dy by dx plus y is equal to radical a square plus x square minus x. Express your answer as it is you get. Integrating factor is x radical a square plus x square. And the answer is y into x plus radical a square plus x square is equal to a square log x plus radical a square plus x square plus c. Is it correct? Okay. Last one in FOLD.
तर ते ई रेस टू लॉग होणार तर ते फक्त एक्स प्लस रूट ऑफ एक्स स्क्वेअर प्लस एक्स स्क्वेअर फॉर्म मध्ये पाहिजे ना लॉग टर्म कशी काय आली?
Okay, last problem in FOLD. Y dx plus 3x minus xy plus 2 dy is equal to 0. Let me write down the solution. You cross check whether it is correct because every student is showing different form. Y answer. Y cube e raised to minus y times x plus 2y square e raised to minus y plus 4y e raised to minus y plus 4 e raised to minus y plus c or minus c is equal to c. Something like this. बघा correct आहे का? Minus of this. That is what is your final answer. Okay. Suppose before telling you a little bit of theory, I give you problem. Let me see if you can solve. Maybe problem number 8. dy by dx is equal to x cube y cube minus xy. Find out. Let me give you the method now. This is not directly FOID, but it is something which can be converted into FOID. So, if we have an expression of the kind dy by dx plus p of x times y is equal to q of x into y raised to n, then how do we go about it? Divide by y raised to n everywhere. Y raised to minus n dy by dx plus p of x to y raised to 1 minus n is equal to q of x. Put y raised to 1 minus n is equal to t. Therefore, 1 minus n times y raised to 1 minus n minus 1. That is the derivative of LHS dy by dx dt by dx. Is that okay? LHS 1 minus n y raised to 1 minus n minus 1 dy by dx is equal to yes. This is nothing but 1 minus n y raised to minus n dy by dx is equal to dt by dx, and hence y raised to this equation which we have becomes what 1 upon 1 minus n times dt by dx plus p of x times t is equal to q of x. Multiplying throughout by 1 minus n, it is FOID and can be solved. So now solve it. Okay, therefore in terms of t, the equation which I will get is 1 upon minus 2 dt by dx plus uh, x times t is equal to x cube, which is dt by dx plus minus 2 times xt is equal to minus 2 times x cube. So p of x is minus 2x. So integrating factor is equal to e raised to integral minus 2x dx, which is e raised to minus 2 times x square by 2. To cancel, which is e raised to minus x square. And therefore solution of this is t into e raised to minus x square is equal to integral of e raised to minus x square into minus 2 into x cube dx plus c. So if you solve this integral, the last integral, oh, it is our friend. We have solved it recently. The answer is going to be e raised to x square e raised to minus x square plus e raised to minus x square plus c. Right? something like this, and then you are supposed to replace t by, what is our t? 1 upon y square, e raised to minus x square upon y square. This should be your answer. This form is known as Bernoulli's form, your same Bernoulli of physics. Okay. We will solve few more problems on Bernoulli's form next lecture and try to deal with remaining types of differential equation in the next. That is where I stop recording.